All right, welcome back to Mr. P. with Precal. This is Unit 4, Topic 3, Lesson number 4. We are going to be writing polar equations from the graphs. So kind of the opposite of the last video. So I added a little graph so I can show you demonstrations of what it would look like, but it says in the warm-up, determine the type of polar curve is formed. So what kind of polar equation is it and why? This one is going to be a rose, and the reason why it's a rose is because there's no plus or minus. It's just 3 times cosine of double angle. So when you make this rose, the couple things you need to keep in mind is, first of all, it's cosine, which means the first petal is going to be along this starting point. The fact that it's an even number, 2, means there's actually going to be 4 petals, and they're each going to be 3 long. So 1, okay, it's kind of hard to read this, I made this so small, 2, 3. All right, so 1 petal is going to be right here. And like I said, this is an even number, and even numbers always get doubled, so there's actually going to be 4 petals. So there's going to be 1 there, and 1 there. So it looks kind of like that. R equals 3 minus. Remember, if it's plus or minus right here, then we're talking about a limacon graph, which is like one of the dimples, or the looped, or the cardioid, or missing one of them. Oh, convex. So anytime A and B are equal to each other, then you know it's cardioid. So we know that it's sine, which means the cardioid is going up and down. So the difference, so let's see, right here. So it's minus, which means it's going to be going down. It's going to be 3 away. 1, 2, 3, 1, 2, 3, 1, 2, 3. And something like that. All right. R equals 2 plus 3 cosine of theta. Okay, before I go on any further, let me just show you that using your graphing calculator, you can graph all of these. If you go under mode, notice that I've changed my settings to right here where it says polar. Normally it would just be a normal function, but I changed it to polar. And it's still going to, you're going to go to your y equals. I'm going to take that one out. That's actually an old one. I'm going to put in the 3 minus 3 sine of theta. Now remember, your X button is really the theta button because you'll see that it's the third one is polar. And then when you press graph, you're going to get a graph that looks very similar to the one that I had just made, although it's, very messy on my screen. And then you can do the same thing for all of these. You just go to y equals, clear that one out, 2 plus 3 cosine of theta. Now, before I even press anything, I should know that this is going to have an inner loop. And the reason why I know it's going to have an inner loop is because A is less than B. So if I press graph, and then it should be showing up, it should have an inner loop on the inside. Now, it is cosine, which is the reason why the inner loop is either going left or right. It's plus, which means that the inner loop is going to the right. If it's been minus, then it would have been inner loop going left. So the inner loop is going to be 2 away, which is right here. Obviously, these are 2 away because of this 2 right here. And then if you add the 2 together, the maximum is 5. 1, 2, 3, 4, 5. All right, so inner loop here. And then from here, something like that. That looks close enough. Now, this one, so this one's an inner loop. I forgot to write these down, and this one is cardioid, and this one is going to be dimpled. Now, the dimpled versus convex is very, very similar. They're pretty much the exact same thing. They're very close to a cardioid, as a matter of fact. The only difference is this little point right here is getting moved to here for a dimpled, and it's moving out here to make it convex, meaning it's not coming back in at all. It's actually still going outwards. That's what makes it convex. All right, so 3 minus 2 is a difference of 1 away. These sides are 3. 1, 2, 3, 1, 2, 3. Oh, actually, I didn't take into account. Am I going the right direction? No, I'm not. So it looks like I'm upside down. It is sine, which means it's going up and down. And this 3 would be along the x-axis. 1, 2, 3. But it looks like I had it upside down. And then 1, 2, 3, 4, 5. Something like this. And put that into my calculator. 3 minus 2 sine of x. And then press graph, and oh, I do have it upside down. Sorry. Exact same thing I had, but upside down. Did I put minus? Yes, I did. It looked like that. Okay, examining Rose curves. So we have this equation and this equation for sine and cosine, where n can be any number. So we're going to talk about what is the equation for these two graphs. So the big rose has a, remember, represents the maximum distance of that petal. So this would be r equals 2 times. Now this happens to start along the original starting point, so I know this is cosine of, this is 1, 2, 3, 4 petals, so that would be double angle. Keep in mind that if it's an even number for n, then it's always going to be double that amount of petals. The small rose is r equals 1, which is the maximum. This is also a cosine function because the first petal starts along the x-axis. And this one's going to be 1, 2, 3, 4, 5, 6, 7, 8 petals, so this will be 4 angle. Can you make any conjectures about rose petals? If it's a sine function, now I just kind of described to you what happens when it's a sine function. Well, it's a cosine function. It's always going to start on the starting point, on the initial starting ray, on 0 degrees, or it starts on the x-axis. If it's whether or not it's going to hit on both sides, that just, well, I guess it always will for cosine. It's always going to hit here and here, unless it's an odd number. That's not necessarily true. If it's an odd number, it only hits on the right side. So if it's an even number, it'll hit on both sides of the axes. So it just kind of depends on whether or not it's odd or even. If it's a sine function, it doesn't start along the x-axis. It's always going to start at 2 pi divided by, pi divided by 2n. Number of petals is represented by, the number of petals will determine whether or not it's an even or odd even or odd n. So an even n is going to have double the amount of petals, and an odd n is going to have that number of petals. The length of the petals is represented by the a term, so the number that's in front. So whatever it's being multiplied in front is the length of that petal. Okay, so one more slide to go. We're going to, forgot to erase. All right, so you already saw all the answers. Actually, you know what? Save me some time. Might as well just keep it there. Keep in mind, sine of theta, remember sine is always along the positive or negatives. If it was negative, it would be down here for a circle. Sine of double angle, so obviously this is 4 petals because like I said before, if it's an even number, it doubles it. I know it's sine because it starts at 45 degrees. It does not start along the x-axis. I know this is also sine because once again, it does not start along that axis. It's 1, 2, 3 petals. This is going to be 4 because this is 8 petals. And this is also sine because it does not start along the x-axis. This one is... Okay, so this question is very similar to this question. The difference is that this one is positive sine and this one's going to be negative sine. So this is 3. Okay, also the length is a little bit different. So this is negative 3 sine because obviously it's not starting going this way, it's going this way. And remember, you can always find that by doing that pi divided by 2n. This one, 5 cosine of 80 degrees. So once again, you can find that 80 degrees based upon what I just said a second ago. And wait. Of 8 theta. That doesn't make any. This is a cosine question. So this is along the x-axis, and there must be 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's 16 of them. There's 16 petals because double this, and the length of each one is 5. So from here to here must be 5. Here to here must be 2, so that's 2 circles. It's sine because it does not start along the x-axis, and it's 4 because there's 8 petals, and whenever it's an even number, it's always double that. Hopefully I didn't leave these with answers. Okay, good. So this one, we know this is a sine function. Well, first of all, 1, 2, 3, 4. So I know it's r equals 4, which is the length of the flower. It's a 45-degree angle, so I know it's exactly sine of double angle, because 2 double that because it's an even number is 4 petals. This one is a cosine question. This would be the length of each petal is 4, so R equals also 4 times cosine, because the first one started along the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, which means it's 4 times theta, because it's an even number. All right, thanks again for watching. I'm going to stop it right there, and then on the next video, we're going to get to systems of polar equations, as you might see right there. All right, thanks again for watching. Have a great day.